Hello and good afternoon. On behalf of 𝗟𝗵𝗽𝗀𝗀 Electronics, I would like you to welcome to another event of our expert webinar series. Today's webinar will be held in English language together with our partner company Proton Electrotex from Orel, Russia. The title of today's presentation is Extending of IGBT product list in standard IGBT housings. The presentation will be given by Mr. Kirill Volobuev. Kirill is the head of the IGBT development department at Proton Electrotex. My name is Ralf Jessler and I'm in charge of the business development at 𝗟𝗵𝗽𝗀𝗀 Electronics in Mannheim, Germany. In the following, I would like to take the opportunity to briefly introduce the company 𝗟𝗵𝗽𝗀𝗀 Electronics. This presentation summarizes our main competences and our offer. I think most of you today know us as a distributor of power electronic components. Beyond pure sales activities, however, our highly qualified sales team offers our customers comprehensive support throughout the entire product lifecycle. In addition to the product portfolio of our trading partners, we also have in-house products such as complete converter stacks or power supplies with reinforced insulation technology. Furthermore, at 𝗟𝗵𝗽𝗀𝗀, we engineer and manufacture assemblies and systems according to customer specifications, usually in range of approximately 100 kilowatts to megawatts per converter stage. Let's have a look at our power electronic components program. Here we offer gate drivers from Power Integration Switzerland, power semiconductors from Hitachi Energy from Lenzburg, Switzerland, or here we are, Proton Electrotex from Russia, as well as from Fuji Electric from Japan. Furthermore, we have high-performance air and liquid coolers and heat sinks from the company MIFA based in Italy in our program. Furthermore, we offer power resistors and high voltage resistors from EBG Austria, current and voltage sensors from Petersen France, and finally, capacitors dedicated to power electronic applications from Elektronikon Gera, Germany, and the Chinese manufacturer Yanghai with their European headquarters based in Krefeld, Germany. If you use IGBT or silicon carbide MOSFETs and module packages, such as those presented today by Proton Electrotex, the high thermal sheets from our partner NeoGraph in the United States could be a good alternative solution. The compressible graphite sheet possesses a thermal conductivity that matches traditional thermal pastes. Assembly and disassembly of the modules are reproducible and generally a clean thing. Pump out or dry out effects do not happen in principle. Compared to the paste, the heat conducting sheet is always very reliable even at higher temperatures. It is therefore really suitable for the heat dissipation of silicon carbide modules. As already mentioned, as at 𝗟𝗵𝗽𝗀𝗀 Electronics, we offer our own solutions such as plug-and-play driver cards for thyristors and IGBTs, which we also like to use in customer-specific developments. Then our modular converter system 𝗟𝗶𝗸𝗀, available in different converter topologies and cooling modes. And finally, our inductive power supplies, which enable the isolated power supply of electronic assemblies at different electrical potentials. The power supplies are powerful and partial discharge-free up to 21 kilovolts. What differs us clearly from the competition are our activities in the field of development of power electronic assemblies and complete systems, optionally with or without control. Today I'm presenting a customized thyristor switch for the use in test facilities. The power electronic switch is capable to block AC voltages up to 24 kilovolts, and in the on state it carries AC currents up to 600 amps. It's equipped with thyristor modules from Proton Electrotex and our own inductive power supply system 𝗵𝗵𝗽𝗁𝗍𝒔. If requested, we are also happy to manufacture the power electronic assemblies or systems developed by us at our location in Mannheim, Germany. We are very flexible with regard to the number of pieces. And as usual here, a small selection of our customers. We would be very happy if we can place your logo here soon, if not already done. Okay, with that, I'm already done with my presentation and call Kirill from Orel, Russia. Hello, Kirill. Are you there?
Yeah, hello. Can you hear me?
Hi, Kirill. Then please give us your presentation. Thank you.
Thank you, Ralf. And yeah. Okay, thank you. Yeah, as Ralf said, I'm Kirill Volobuev, head of IGBT development department from Proton Electrotex company. We're a company who develop and produce semiconductor devices for more than 25 years, and last 5 years we are producer of IGBT modules. So today's topic will be regarding some new lines of IGBT modules which were developed last few years, and today we start producing it and selling them. So we are going to speak about 1200 volts IGBT modules, and here is a short overview of these modules. We call them MA and ME series. Before now we produce only FA series, and as is a part of part number of our modules which connected with supply of chips. So these new lines of modules were developed and now are producing with new chips which we get from our Japanese partner. It's a independent Japanese company which developed silicon chips for more than 40 years. So we are sure that the experience is more than enough and they can produce competitive parts on the market. What are the reasons to start this project? Of course, it's performance improvement. Because you know that progress is a usual part of every business, and everyone wants to be better. So we are the same, and of course we are searching all time for new technologies, for new supplies, and so on. This was one and maybe the main point, but nevertheless. We're also thinking about price and try to reduce it as much as we can to be more competitive on the market. Again, dies supplier diversification is also essential for each producer of power modules. So we try to diversify our supply channels, and we're really happy that we started before maybe 2 or even 3 years ago to communicate with this new supplier, and right now we don't have such lack of chips that some producers have. And of course, product line expansions. We want to expand our lines regarding nominal current, for example, or other parameters. And I will say about it in more detail later. So as I said, there are two families of modules, MA and ME. How we separate them? MA is like absolute power and performance modules. So it's, let us say, a high-end product, maybe not, the best of the best, yeah, but it's more than competitive on the market. And in contrast, ME series is like economy modules. It's not, I can't say that they're cheap and don't have such performance as all other modules on the market. But there is a good balance between performance and cost, what we try to implement in these modules. Okay, now I'd like to speak about what's inside these modules. Inside modules is, of course, IGBT and FRD diode. And IGBT is built as a trench gate fill stop technology. So it's up-to-date technology. And you can see there are two pictures, two graphics, where we try to compare these chips with other families, which, for example, FA series, which we produced before, and okay, we are producing right now. And the fourth generation, speak it's generally, yeah, the fourth generation of market, which other producers have. And regarding IGBT, you can see there that the left and the bottom is better, yeah, and MA series, it has very low voltage drop regarding other competitors, yeah, even FA series, and practically both MA and ME have the same energies. So I would say that MA series is one of the best in this state on the market. And going to FRD, you can see that both MA and ME series are better than usual generation 4 and even FA series, which we are producing. Yeah. Okay, it's what I want to say about chips. And let's see more detail. What are changes what changes were made with module and how it react on its parameters. There are graphics which show you comparison with our internal 3 series modules, which we can detailedly analyze and have a lot of statistics. So it's very representative data, which we in which we are sure enough, and you can see there that voltage drop in IGBT of ME series is the same that FA series. So it's the same performance, but I think that it will be more price. The price of it will be a little bit less, I suppose. And MA series is much more better, both of them. The same about Yeah, the same about diode. Voltage drop of both ME and MA series are less about 15% than FA series. Going to dynamic parameters. Energy of IGBT. Energy on is dashed, and energy off is just colored. So both ME and MA series are better than our FA series, which we are producing now. And going to diode, it's more than IGBT. The performance is better for about 20–25%. I guess it's a good benefit of these modules. Going to gate charge. It's a usual question for us that our FA series modules has rather big gate charge, and not every driver suits our modules. That's why it was one of the topic which we can try to solve, and in this new series we, I guess, do our best with the help of our partner, and we reduce gate charge more than half. And now I can say that from my point of view, every driver on the market can turn and off our modules, ME and MM modules. And thermal resistance is one of the main parameters of modules, semiconductor modules. You can see there that both with new chips and with the help of new design, internal design especially, we reduce thermal resistance of our modules of MA series for 10%. And as we try to make the best between price and performance of ME series, we make it the same as FA. Well, yeah, it's what I want to say about general parameters, the most important ones. Go on. About line expansion. Let's say white modules is what we have before. It's FA series, and a little bit with light blue, yeah, the color is in new modules, both MA and MA series. So we have right now 3 types of cases. It's MIFA, MIFA, which is 34 millimeters baseplate wide. So there are 4 new models. MIAA, which is 62 millimeter wide. There are 7 new models. And MIDA, which is like EconoDUAL type, there will be 6 new modules, which were developed and which are right now. Let's have a look more detail on each type of case. What currents we have there. According to MIFA, both ME and MR series are built with 100 amperes and 150 amperes, as well as our old FA series. They will be with circuit types as half bridge, high chopper, and low chopper. And on the right side of slide, you can see graphic of comparison our three modules, which is red, green, and blue, and generation 4 of European producer in comparison. It is current and frequency. So I guess it's one of the best options to compare modules. If you want to compare them, to just build such graphics, because you can choose what frequency you need and what ampere you usually use, and on it you can on cross it you can find what module is better. So the more left side and to the bottom, the better. Here you can see that MIAA series is practically, and just not practically, but the same as generation 4 in this type of case. FA series is a little bit worse, and ME series, let's say, worse for performance. But as I said, we try to build a module which will be both price competitive and performance competitive. Here it is, MIFA modules. Go on, and MIAA modules. Here you can see that we designed the same amperes which we have FA modules, 200, 300, and 400 modules, for sure, as well as MIFA, 𝗬𝗵𝗽𝗁𝗁, 𝗫𝗫𝗃𝗃, and 𝗫𝗫𝗃𝗃. But we expand our line with new 450 amperes and 600 amperes modules, which we haven't got before. And as well as slide before, let's compare modules in this case with each other. So here we can see that our MA module is, well, let's say, the best of these 4 ones. Generation 4 is a little bit worse, and FA and ME series are the same. So in this module, we do our best, to make as good module as we can with these new chips. Okay, and the third one. Okay, yeah, I have a slide. What we was working about inside our module. You can see there a picture or a typical picture of internal layout topology of 62 millimeters modules. Here usually 4 plates, and in each plate there are IGBT and recovery diode, and lines placed here is a gate circuit and power circuit, which is dashed. So we try, you can see how big loops there are, especially gate circuit. And for sure, I guess you know that the more loop you have, the worse parameters you get. So we try to recombine these loops such that our dynamic parameters, especially energy on of both switches of, let's say in these modules, switches between terminals 1 and 2 and terminals 1 and 3 will be more balanced as we can. For sure, we can't make them equal because well, inductance of them are different. But in our hands is to minimize this disbalance. And here you can see a comparison of energy on this balance between these two switches of FA family, which is about 25%, competitor, which is generation of 4 module of the same case, has about 30%. And these new modules, both MA and ME, have a 13% disbalance, which is more than 2 times better. So we work a lot to change internal layouts to the best performance without increasing price. Yeah, and to go into EconoDUAL type. Here are 2 different big jobs were done. First one, of course, it's work with new supplier and new chips. The second one is with modules case. Let's speak about new design, new modules rates. Here are 340, 450 and 600 amperes modules, the same as we have in FA family. And again, we expand our line and build 750 amperes module with this with the help of these new chips. Yeah, and okay, let's again compare modules. Here are 5 graphics, because here we try to compare not only this generation 4, which on the market, but the last generation 7 modules, the same current rate, and have a look what we get. We calculate lots and check everything, maybe not double, but 10 times, and we get what we get. So the MA series is the best one in comparison of these 4 modules. Then we can see that FA series, then ME, which is practically equal, especially on a frequency about 12 kilohertz, and only then we can see generation 7. Why it's so? Because you can ask me, and I have some points about it. First of all, what is generation 7? Of course, everyone says that there are chips with lower voltage drop, but at the same time they reduce size of these chips a lot. So it changes the size of chip changes thermal resistance of the whole module and make it worse, much worse than it was with a bigger chip. That's why it can't make as much power and spread all this heat which it produces, because it has just smaller sizes. And at the same time, some producers change the heat sink, or a base plate of a module, change its material, but it's also sometimes it causes also the increasing of thermal resistance, Yes, maybe there are some points that the performance of module in general are better, but speaking about its current characteristics, the power of module, fortunately, in these comparisons, we saw that it decreases, which usually is not said by those who produce these new modules, but you can find it by yourself, just examining it, data sheets, especially thermal resistance parameter. Okay, and next slide shows you improvements of a case which we done. We also work a lot with case design, because let us say the first module we make in a little hurry, and maybe we are not have a lot of time to make it the best which we can. But in this generation, we try to solve these things which we suggest we are not as good as we want. Here are all improvements which we made. Let's start from, I guess, the main ones. We develop modules both for solder contacts to solder module to a driver board, which is on the upper side of the module, and both press fit contacts for those clients who use such kind of driver board design. Then let's go to the right. We improved terminal flatness, power terminal flatness, and we suggested will increase mount surface to the bus bars, and the resistance between power terminals and bus bars will be smaller, and of course it is better for all inverter design. Then we increase creepage distance between our DC terminals by improving this case design, make some change it outside surface. Then we implement a better case to base plate fixation. I don't think that it is one of the main features, but nevertheless, we suggest why not to do it if we start the redesign our module. Then PCB supports were added. They were added more supports along all contour of drive board to not to bend drive board when you solder it or to press it to the module. Of course, internal design layout optimization. We change it and we do it more robust, we do it more technological, and it also increase its cycling capability of this module. Also, we add some marking on cover to make connection of module more easier for clients. You don't need to have a look, every look on datasheet where each pin where. and just have a look on this cover, and here are all numbers. And also we make better cover fixation to the module, because we by ourselves we're not very satisfied how it really fixates in our old design. From now we are producing only such kind of modules of design of our MIDA modules. It's for all types of chips, for FA, for MA, and ME series. It's all the same, and these features are implemented on all types. Okay. Yeah, it was generally all about new series, speaking about MA and ME series, but I have just few words about our current roadmap, our current projects. And if you would like to get more detailed information about them, just type in the chat or contact Ralf, and we can make another presentation regarding these topics and discuss it more detail with you. Let's go from left to right. Here is MIHA module, which has the same footprint as MIAA. It is 62 millimeters module in width, but with increased isolation. It has isolation up to 9.5 kV AC for 1 minute, and we were asked from some of our clients to produce such module, to develop such module, because they use modules in really harsh environment, where it's rather wet and with a high humidity and with a lot of dust, like railways, for example, and they need a lot of isolation to be sure that all the inverter works in safety conditions. That's why we develop such kind of modules. It's 1.7 kV modules. Current rate is up to 400 amperes. And yeah, and also the other feature of it, that it has minus 60 degrees storage temperature. So we change internal materials to be sure that module can store in such conditions. Unfortunately, we can't, or we can't right now say that it can work from minus 60 degrees. Usually it's start working from minus 40 degrees, but let's say we just don't need it right now. If we have such task, we also can do, and we have thoughts how to do it, how to make its operating conditions from such temperature if you need. But of course, it's usually the ask from Russian market, where winter is cold, especially in Siberia. Next module. Next module is MIXM module, and you can see that it's one of the most discussed design in the market for maybe last 3 years. And we also are developing such kind of module. We have now prototypes of it and test internal a lot, redesign it and test again. And we are going to release it on the market in the end of next year. So it for sure will be 1.2 and 1.7 kVs voltage rate, and right now current is 1.2, but we are working on to increase this parameter to make it better. This module will be in two different designs for industrial application and for vehicle application or traction application. The difference will be in its package, especially base plate, to make it more reliable, to make traction application more reliable than industrial one, because cycles are higher here, and such modules work in more harsh environment. Okay. Next two modules, I will group them. It's MISM and MIHM modules. It's well-known modules on the market. Some companies produce it for maybe 10 or 15 years, but we didn't have it in our portfolio yet, and we are now working to change it to start producing such modules. Right now, there are also 1.2 and 1.7 kVs for different currents, depending on different voltage rates. These modules we make only for vehicle application. Of course, it doesn't matter. Seems that you can't use it. It's for industrial, but and we can also develop just module with some better performance, but not so reliable as transport application. If you need, we can customize them. It's not a problem. We know how to do it, but right now we don't have such task. We design only for vehicle application these modules, and we also want to release them in the end of the next year. So these modules are practically in one stage of designing right now. And the last module, which I would like to discuss with you, is silicon carbide module in what it looks like EconoDUAL type, but except footprint dimensions, it has nothing common with EconoDUAL type, because all its case design and internal layout and everything is changed deeply to suit silicon carbide performance. So right now it's 1.2 kV and up to 500 amperes rate, depending on internal socket. We also, for sure, it's modules with low inductance, as I said. It should be suitable for silicon carbide frequency. Module is practically ready, and we were ready to release it this year, but with the supply chain and with this boom on the market, especially in silicon carbide market, with suppliers of chips, silicon carbide, so our company also start to be with long-term conditions, and we had to reschedule release of this module to the next year because we are waiting for dies, and this is the only thing why we are not released it this year. For sure, all these types of modules could be suited with our own driver boards, which we develop and produce in our company, if you would like to. But if you have your own design or just buy it from other sources, it's not a problem. We can also give our support to you and discuss with you in what conditions, how to implement what driver where, and so on. Okay, I guess it was all from my side. Yeah, thank you for your time, and if you have questions, feel free to ask.
Okay, thank you very much, Kirill, for this very interesting presentation about your IGBT program. This brings us now to the Q&A session. So, dear participants, please make use of the chat function for your questions and comments. So, if you wish, you can ask in German language or English. Unfortunately, not in Russian, or maybe Kirill can translate.
Yeah.
But while we are waiting for the feedback from the attendees, Kirill, I already noted down some questions to you. First question is, will the MA replace the FA series, or will it continue producing both series in future?
Yeah, very good question. I can right now we don't want to change FA series by MA series, and would like to produce all three series in a row, let's say. But it depends from our customers, from our clients, what they want. And of course, if we saw that FA series goes down, we will maybe rethink this. But so everything depends on the market. You can see how fast it changed right now, and we need to be ready for it also. Mm-hmm.
Okay, thank you. So, what is the lead time for the new modules?
Again, good question. Today's lead time of MA series and the ME series doesn't matter. We have on stock some stock of these chips and can produce it like in a usual delivery time. But if the quantity is big enough, we need to plan our production. We need to plan our with our partner, with producer of the chips. But it's just a question of discussion. I guess it's not a problem.
Okay, thank you. Another question is, does Proton Electrotex face any deficit of dies at this time?
As I said, we have some deficit with silicon carbide dies mainly. We don't have deficit with IGBT or just general silicon dies, and we work deeply with our suppliers to plan next year. So I can't say that we have some problems there.
Okay, good. And one question about your gate drive circuits, gate drivers. Are your gate drivers for the FA modules are also suitable for the MA or ME modules?
Yeah, thank you for this question. Yes, our modules for FA series is power enough to drive them. For sure, they will be suitable for these new families ME and MA.
Okay, thanks a lot. And last question, has your production line enough capacity to produce all 3 series without extending the lead times?
Yeah, it's also a question of planning, but right now we don't have any increase of lead time and can produce as well FA series and our new MA and ME series at once. So if we have a right plan from our customers, there will be no problem.
Okay, thank you very much. So there is no further question. Thank you, and bye then.
Yes.
Bye-bye.
Thank you, Ralf. Thank you, colleagues.